The Indian Association of Structural Engineers, also known as IS-Struct-E, was conceptualized and constituted in the year 2002 by a group of senior professional structural engineers from all over the country. IS-Struct-E is registered under the Society's Registration Act 21 of 1860. IS-Struct-E is a national apex body of structural engineers in India with a mission to promote structural engineering profession and cater to the professional needs of the structural fraternity. In the short span of 2 decades, association has attained an eminent position in the professional field. Its membership is valued very highly in the profession. Since inception, IS-Struct-E has been led by eminent structural engineers like late Shri Mahendra Raj, late Shri Kumar Ghosh, Shri Subhash Chand Mehrotra, Professor Mahesh Tandon, Shri Alok Bhaumik, Shri Manoj Mittal and Professor R. Pradeep Kumar as its president. IS-Struct-E is a permanent member of Engineering Council of India and interacts with the government on professional and policy matters related to civil and structural engineers. To expand its reach, IS-Struct-E has collaboration with various international professional like-minded associations and institutions. IS-Struct-E's prime objective is supporting and protecting the profession of structural engineering by upholding professional standards and acting as a mouthpiece for structural engineers in India. IS-Struct-E endeavor to ensure that its members develop the necessary skill in structural engineering and work to the highest standards by maintaining a commitment to professional ethics and standards. IS-Struct-E is actively engaged in organizing several continuing professional development (CPD) courses for structural engineers to help them update their knowledge and advance their career paths. It also conducts refresher courses for young and practicing engineers and student-oriented programs, seminars, workshops, conferences, technical lectures and discussions related to the latest technological advancements, and case studies are also organized regularly for members to enable them to continuously update their knowledge and skill set by interacting with the best minds from the industry. IS-Struct-E's activities are widely appreciated and known for quality technical contents. IS-Struct-E is also actively engaged in publishing its quarterly journal Structural Engineering Digest (SED), code commentaries, professional guidelines, and a monthly newsletter. IS-Struct-E's publications are becoming popular with time. IS-Struct-E has representation in various technical committees of BIS and IRC as well. Its members are actively contributing to National Code of Formulations. In the year 2020, IS-Struct-E started National Awards competition to stimulate interest in the structural engineering field and to promote innovative thinking and creativity. The awards are presented to the winners in recognition of their outstanding contribution to structural engineering in the categories which include Outstanding Structure, Outstanding Structural Engineer, Outstanding Woman Structural Engineer, Promising Young Structural Engineer, and Best Master's Thesis in Structural Engineering. IS-Struct-E is currently operating from 4 regional centers, namely Eastern, Western, Northern, and Southern, having its headquarters in Delhi to inculcate the professional culture and provide handholding to the budding engineers. IS-Struct-E has its student chapters in several leading engineering institutions as well. Membership of IS-Struct-E is open to all civil and structural engineers engaged in structural engineering profession. Members are elected based on their qualifications and experience in different grades as per eligibility requirements prescribed in the bylaws. Each application is carefully scrutinized before electing the members. More information about IS-Struct-E is available on its website www.isstruct-e.co.in.
Hello, Vikas, my voice is
Yes, sir.
audible?
Yes, sir. Yes, sir. Please start.
Dear friends, welcome to participate in this webinar. Today's topic of the webinar is Structural Audit and Assessment in Protecting Built Environment by Engineer Amardeep. Regarding brief about the speaker, Engineer Amardeep graduated from NIT Kurukshetra in 1997 in civil engineering and further obtained postgraduate diploma in construction management from National Institute of Construction Management and Research. He is a chartered engineer and has over 28 years of experience in the profession. And he has been working in the construction technology. At present, he is the managing director of Creative Design Consultant and Engineers Private Limited. He is a very active member of various BIS committees, including IS 456 and National Building Code. He is also a professional member of Indian Institution of Engineers and the Indian Concrete Institute. He has published various papers at national and international level on concrete durability and structural safety in seismic sensitive regions. Engineer Amardeep continues to serve as an expert on various technical committees. Brief of the topic. Today, as I said, the topic is structural audit and assessment in protecting built environment. And in this, as we know, the present rapid urbanization, where aging infrastructures, environment challenges, and stringent safety regulations demand proactive, robust solutions. Structural audit and assessment are essential tools for identifying hidden threats to the existing structures, such as dampness, corrosion, cracks, and material fatigue, etc. Ensuring the structural safety of building, bridges, heritage structures, and a wide range of infrastructures and existing assets within the built environment. The webinar would encourage the audience to know the basic tools and techniques employed to tackle the hidden challenges of knowing structural audit process. In here, the speaker will also discuss a few case studies of the structural failure and collapse. Now over to Engineer Amardeep for further proceedings. So, Engineer Amardeep, please continue.
Thank you, sir. So, a very good evening to all participants. Today, as Dr. Dhawan has introduced, we would be talking about the structural audit, how we should be able to preserve our built environment, what are the opportunities, and what are the procedures and systems, and how the legal system, techno-legal system is going to help in this domain in near future. I would like to throw some light on that. And so to start with, I just take up my presentation. Okay. I hope my presentation is available, is visible.
Yes, sir. Yes, sir. Yes.
Okay. So the structural audit and assessment is now a hot topic in civil engineering profession because we are seeing a lot of challenges and accidents also in the existing built environment. Whether it is the earthquake or other natural disaster, or maybe heavy windstorm, or maybe earthquake, or maybe general deterioration, and without any disaster reason also our built environment is collapsing. So how we are prepared to save the built environment, because in our general engineering we are taught to design and construct the new construction, the new building, the new bridge, new road. So we are focused during our academics is towards new development. But lot of built environment, the lot of construction has already been taken place in our country and worldwide. Because generally, as a layman, if I see a building, I feel that okay, this building is there and it should be working for so many years without any problem. So maybe many of us would not have any idea what is the general life of a building, whether we should expect 50 years of a safe life of a building, or 75 years, or maybe 100 years, or 200 years. We are seeing some temples and special buildings, maybe 500 years old, or maybe more than that. But we are seeing some buildings which are just 15, 20 years old. And we are seeing the collapse, or the status of distress is so high that they are declared as unsafe. So, so what is the correct way of designing, and what is the correct way of preserving the built environment? So we get insight about the new construction ideas when we see the existing building, how safe they are, how fast they are deteriorating, or how we are able to save them from deterioration or the distresses. So my today's discussion presentation would be focusing on the key aspects of audit and assessment. So I take my slides, and then in between I would continue to discuss on the current scenarios, what is going on in our national standardization system, and what is the international scenario. So let me start with a heartbreaking slide that we see in Chandigarh. There is a 60-year-old commercial building which collapsed in January 2025. So the preliminary assessment suggests that some factors which are responsible for that could be the aging of the structure, or maybe the earth, because of the earthquake zones. If for a small earthquake part also, it could go high damage. Now, structural stability certification was not there, and the building was taken up for renovation activity. They may have bypassed some important safety aspects or checks before taking up the renovation. It is possible that lack of temporary structural support system for the safety measures were missing, because many a times what we consider as a layman, I would say that some interior decorators, those who do not have engineering background, they generally do not foresee any requirement of any supporting system or passivation of the load path, and they just open up the structure, and they sometimes remove the walls and columns also in the building and make them vulnerable. So this incident highlights the need of the greater compliance with statutory safety protocols, timely audits, and involvement of the technical people, uh, who should be able to guide the safety aspects, as well as any renovation, any modernization, upgradation. If any existing structure is going to have, it should be dealt with a proper technical background. Another slide which shows us the issues of the neglect, or I would say technical neglect or technical incompetencies. A 6-story building in Surat collapsed following heavy rains. 7 people killed and more than 15 injured. Similarly, another 18-story residential tower slab from 6th floor to 1st floor pancaked down, killing 2 residents in Gurgaon. So so there are many things which we are many of such kind of news we are seeing for last many years. And the probable reason of this kind of collapse could be the corrosion of the reinforcement of the building, especially if I see the buildings which are having basements and stilts. Those areas are generally neglected for structural safety, and deterioration distresses starts at the base level. And from the base level, if the column reinforcement goes down, or maybe the concrete gets deteriorated, cracks, the structural capacity reduces a lot, and the earthquakes make them vulnerable for larger damages. So routine checks and audits were not there for these buildings, and unauthorized renovations carried out in lower floors. Cracks and water seepages had been reported earlier, but people ignored. Builder and RW did not take any appropriate action. And further, we find the compliances with the Indian standards and especially National Building Code recent, which is 2016. And I must inform that the current code, National Building Code, is under revision, which is likely to be updated as National Building Code 2025. So in Haryana Building Code has been undergone revision also, and new safety guidelines are being developed, and the country is looking towards the safety of the buildings. So the key observations, what I find is the aging infrastructure for these kind of accidents or deteriorations. Many accidents involve structures over 30 years old, and highlighting the need of the regular maintenance and audits. There are many unauthorized constructions which are non-engineered design without any engineering involvement constructed and not maintained. So those buildings are at severe risk. The buildings what we call as sometimes the general builders floors, buildings, they hardly involve technical people, and more focus is on the commercial gains. So for them, they say this is just a business, but for us, it is a profession. And as a profession, we have to see the building should be safe and should survive for its service life, the design service life. Now, what should be the design service life of a building? Our general assumption is that for a very severe earthquake handling, we consider 50 years as a safe design life of a building. But if we see the infrastructure projects like metro railway stations and other important buildings, probably we want them to live more than 100 years. So for different types of building, we may have serviceable design life of different time, maybe some temporary structures requiring 25 to 30 years design life, but generally what we make a permanent building, and that permanent building should live, in my opinion, should have at least 75 years of safe design life without much intervention requirement, without much maintenance cost involvement. However, general routine maintenance is required for all the buildings. We find during the audits that the buildings have poor quality materials. Construction practices were not having very sound quality system. We find a lot of technical issues in the workmanship of the constructions, and these small errors, small shortcomings may become big when it comes to the safe habitation or safe life of the built environment. And the most important aspect is the neglected safety audits, because once we construct a building, we generally have in our country for 1 year defect liability for the contractor. And within 1 year, if something comes out, that is the responsibility of the contractor to maintain it, repair it, or rectify it. But after 1 year, we generally ignore everything, and then one day we find the building has got deteriorated to a very bad shape. Distresses level reaches very high, and the building becomes very unsafe for the habitation. So this is another aspect. Now, what is the way forward? We all know that we have to preserve our buildings, our built environment to a safety level where we can use these buildings and infrastructure without any fear of safety. So what is the way forward? The way forward is the strict enforcement of the building codes, our Indian national codes, whether it is IS 456 for the built environment for concrete structures, or maybe IS 800 for steel structures, earthquake safety codes, and so many guidance and everything is given in National Building Code of India. And if we are able to strictly follow the requirements of National Building Code, many of the issues related to the safety could be covered, and we can find our countries and built environment to be very, very safe. So we have to prevent the unauthorized developments, which are generally non-engineered and not taking care of the requirements of the building codes. Now, the important part what today's discussion of this, the center of the discussion is the structural audits. Now, built environment should be audited at a very, very regular period, very small frequency of period. I have been insisting that for a new building itself, first audit should be within the 5 years of construction, preferably after 3 years, because whatever building you construct, there is a settlement of the ground. The foundations are designed for some settlements. You might be aware, the isolated footing building are likely to settle maybe 20 to 50 mm. Raft foundation based buildings are likely to settle maybe 75 mm or so. Even the buildings on piles can settle up to 10 mm. So almost all types of foundation systems allow the building settlement, which will take place in initial 3 to 5 years of the construction time. So after construction, if we audit the building within 3 years, what we could find is that the effect of the ground settlement, whether it is uniform or differential, then the building should have lived in these 3 years to handle the temperature variations. Because in summer the building expands, in winter it shrinks, during rainy season it gets wet, so dampening effect. So in 3 years we would generally know which are the areas which have leakages, which have dampness, where is the trouble areas, which are the areas which we need to take care. So within the 3 to 5 years of the new construction, if we make one mandatory structural audit, and then after the audit, based on the findings, if we do the rectification repairs, because in the initial time it will be basic repairs only which are required, so it will not be much cost, but it will help the building a lot. And if you are able to take care of the building within the 3 years or 3 to 5 years with the help of the structural audit, then probably we would be able to increase the life of the building to a great level. It is just like a scenario when a newborn child, because at the stage when the child is just born or having the age of 2 to 3 years, there are likelihood of a lot of diseases, and because the body is weak. So at that time, we get the children to be given as the immunity doses. A lot of special care is being done, and if the child is taken care at this age, then the likelihood of having good life ahead is the probability is very high. Similarly, for the buildings, I consider when the building is new, we need to take care it well. And just like our body, when we get some small ailment, we need some medicines. Similarly, if we are able to take care of the buildings with regular structural audits, and whenever a building needs some care, with care means some small repairs, some actions, some points where the building is feeling illness. If we are able to take care it on time, the building is going to live quite good life. So that is the basic advantage of the structural audits, which if done regularly, we are able to take care it well. the cost will be less and we will get a lot of advantages, benefits. I will show you in my other slides. The way forward again is the public awareness, because as a technical person, you would be knowing that this is required. You would be knowing the benefit of the structural audits. But if the public is not aware, then they will not cooperate. They will not take any initiative for that. So to educate the stakeholders about the importance of building safety, maintenance, and the structural audits, if we are able to give the proper public awareness, then the structural audits would be really meaningful. Now, again, the way forward, we should always look for good quality products, good quality materials, and should promote the use of certified high quality materials in construction repair. Through BIS, there is a mandate of ISI marking on certain products which are essential, like for cement, steel, your product should definitely be having ISI mark. But in certain material aspects, the ISI mark is only a recommendatory. But if we are aware and we want to have quality construction, we should insist on ISI mark products. And further, the way forward is the transparent record keeping. Generally, in our construction projects, we find that the quality documents are, I would say, fudged, or I would say not maintained properly. And it is recorded only to show that everything is all right. But when we do something, there are likely mistakes, or maybe I would say there would be chances of some errors also. And if we are able to, during our quality checks, during our quality control testing systems, if we are able to get some information about some errors or something which is requiring some improvement, then if we are able to take corrective action and required all preventive actions, then our construction built environment is going to be a very good for the future. So coming to the advantages or benefits of the structural audits. So why audits are critical to the built environment? So first of all, it is giving the safety to the occupants. It prevents sudden failure or collapse. As in the initial slide I showed, some balconies you would see collapsing, some handrails you see collapsing. These are the general news we see almost every week or so. So if we conduct structural audits regularly and we are concerned about the safety of the occupants, and we are dealing the buildings with proper care, and we are able to provide the repairs and rehabilitation systems to the building properly, then first advantage we are going to get is the safety of the occupants. So it will avoid any fatalities or injuries, and it ensures the complete safety regulations. Now, in some cases, the buildings use type or the loading type needs to be changed. Sometimes a residential building becomes commercial building, or a commercial building becomes a storage area. So it has increased the load. Sometimes what happens is that a factory becomes showroom, or a showroom becomes factory. So many a times, or sometimes a normal building becomes a library where you have a load of books, or sometimes some warehouses are created within the building. And many a times now what I see is that because of the IT impact, a lot of buildings have data centers, and because of the data center, they have UPS room, battery rooms, and certain other heavy load equipments in the general building. So general load is varying in the existing buildings itself. So if the change in use or loading is there, then again the structural audits and the structural safety guidelines would help the building a lot. If we are just ignoring the structural requirements and just putting any load on any aspect or any floor, then again we are inviting the risk. So in change cases, again the structural audits helps a lot. Now again, if as the infrastructure is aging, with the age, there are certain structural elements which can become a bit weaker, and those weak elements need to be strengthened. So with aging infrastructure, if we are complying to the structural safety audits, then it will comply with the legal requirements, avoid penalties or notices, provide documentation for clearances and certifications for the existing buildings. Again, structural audits are important for the post-disaster assessment. If after the disaster, if any building is being considered as safe, even if it is looking to be safe, again, structural audit is required to confirm what is the residual strength of the structure. It should not mean that if the structure has withstood a disaster, it will withstood another disaster also. So if it has taken care of a disaster, then what is the residual strength, whether some damages have happened in the structural elements or not. And if some damages have happened, what is the need of the strengthening or the retrofitting for those elements? And with the help of all these assessments, we can again make that building safe and habitable. And again, now it can have sufficient residual capacity to withstand another disaster. Another advantage what we get from the structural audit is the cost-effective maintenance. Now, if we are having timely audits every 3 to 5 years, we would know what is the requirement at that time, and with the small cost of repair, we would be able to timely maintain that building. If we are ignoring the audits and if we are ignoring the safety repairs, what would happen? Say after a long time, the deterioration will be very high, and then if we want to retrofit it or rehabilitate it, the costing could be very, very high. So with the help of regular audits, we can save a lot of cost of the building during its service life. Again, now coming to the advantage is the regulatory compliance. As per our National Building Code of India, each and every building should have structural safety, fire safety, and electrical safety audits every 3 to 5 years. So different regulatory bodies define the structural audit requirements because it's a state matter. Ultimately, the either municipal corporation or authorities, they will define the period of audit and the compliances. So if any regulatory body says that every 3 to 5 years the audit has to be conducted, then if we are following this requirement of structural audit, we would comply with the legal requirement as well. So if you get any letter from any authority or the municipal corporation that please show your building safety certificate. So if you are having your audit done regularly, then you can easily show the building safety certification. So this is the benefit. And then sustainability goals. Now, if your building is going to live long, it is a sustainable aspect because constructing a new building consumes a lot of energy, CO2 emission. All building construction elements are consuming more and more carbon dioxide emission materials and energy consumption. So if we are able to make our building life better, longer, so it is helping us in our sustainability goals. So it is a kind of reducing construction waste, saving natural resources and energy, aligning with the green building principles. And further, you get advantages for the insurance and valuation. Though in our country at this moment, our insurance premiums are constant, but it is likely that in time to come, the buildings which are constructed good, maintained well, may have lesser premiums than those buildings which are not being maintained properly. So if we have regular technical audits, structural audits, safety audits, and we are complying to the safety requirements, our building insurance benefits and the valuation benefits will be higher. Now coming to, until now we discussed about the benefits of the structural audit. And now briefly, I would discuss the how audits work, tools to tackle the hidden challenges. Now for that, I would now just discuss the steps involved for the structural safety audits. So first step is the document review and the critical visual inspection of the structure. Document review means the document of the construction as built drawings, probably if available geotechnical report or any in between, if we have done some repairs and strengthening work, some interventions, if the building has undergone in the past, documentation about that. And with the help of critical visual inspection, we try to assess the condition of the building. Whatever we assess based on the visual inspection, then some things which are not visually auditable, we do non-destructive tests. There are many types of non-destructive tests which are helpful in assessing the building. There is a guideline, a document of IA Structi. It is available on the website of the IA Structi. And this is a small document giving the brief description about how to audit a building and what kind of non-destructive test we require for a system, for the audit system. So you can get details about that from their document also. But at this moment, I'm just giving you the brief idea that this is the requirement. Sometimes we are not able to completely assess the condition of the building based on non-destructive tests. And we need some partially destructive test. Partially destructive test means we take some samples out of the building and take it to the laboratory and test in the laboratory. Non-destructive tests are those tests in which we are not disturbing the building. We do on the surface rebound hammer test or some ultrasonic pulse velocity test, maybe half cell potential test, concrete resistivity test. So some tests we can do on the surface like moisture level test. So these tests are non-destructive. We are not harming the building at all. But if those tests are not sufficient, sometimes we have to take samples. So for that, we do some partially destructive tests. Partially destructive test generally we consider as core sampling test. With the help of core, we do sometimes chemical test. In chemical test, we have pH, we have chloride assessment test, and then sulfate assessment. Generally, these 2-3 tests are required if we have to go for chemical assessment. With the help of core, we do compressive strength test also. And all these things are taken in the laboratory. And then based on all the findings of the documents, critical visual inspection, testing, we get to know a lot of information about the building. And based on that, we can do the structural analysis, or maybe simply, if the building seems to be good, we can simply analyze the findings of the test results and then recommend the building interventions or safety certification. So we see a lot of things we have to do when we do the structural audits. And in that scenario, I would say that it is a multiple tool synergy. We have, if we do only one aspect, if sometimes what we find in the market is that some people only do visual inspection report, visual inspection, and based on that, they provide the report of say certification that visually everything is fine, so building is fine. So it is a very raw assessment if we declare based on visual inspection. Generally, it should be supported with a little more information about the internal conditions with the help of non-destructive tests or maybe some partially destructive tests. Sometimes we have to dig for the foundation sizing also, and sometimes we have to assess the condition of the concrete and reinforcement at the base level also. So just based on visual inspection, we should not certify any building to be safe. Yes, of course, visual inspection is required to have initial assessment, and then other tools like non-destructive and laboratory test helps for the complete condition assessment of the structure. So with this integrated approach, we take up the complete audit and assessment. And I'm happy to tell that at BIS level, at Bureau of Indian Standards, we are developing a standard for the engineers, for the structural engineers consultants, that how to take the structural audit as a consultancy. So the standard is at its advanced stage. Almost everything has been discussed. The document content is being finalized, and probably within this year, the Indian standards on structural audit would be available for all. So based on the current level of working at BIS and my own assessment, and as per our past experiences with the audit process of structures, we find there are different stages, generally 5 stages we consider of audit. These 5 stages are not for the audit as such, but audit stages are mainly 3, but for the complete 360-degree completion of the audit process, I consider 5 stages. First stage is the visual inspection by a competent structural auditor. Second stage is the non-destructive testing, maybe partially destructive testing also covered within this. And based on that, finalization of the audit report. And in this audit report, we consider it to be a kind of condition assessment audit report. Now, if we have assessed the condition, if the condition is good, that is fine. If the condition is not good, we go to stage 3, in which we require some strengthening intervention design. And all these designs will be taken up by a competent structural engineer, and it has to be vetted by the structural auditor who has the complete analysis of the condition assessment findings. In stage 4, it is kind of implementation of stage 3 by a competent execution agency. Now, in our country now, there are many good execution agencies who are trained and developed themselves to be working for the retrofitting, rehabilitation, and repairs of the existing buildings. And once the execution is completed, the building has to be reassessed for the purpose compliance, whether the implementation and the intervention has achieved the original goal of safety, then post implementation of audit verification of the executive orders. So it is a kind of re-audit of the structure after the execution of the intervention or the strengthening has been completed, to assess whether the desired goals have been achieved or not. In this post implementation of the audit part, generally we conduct non-destructive tests only, and in which sometimes we find UPV and some other tests to be very useful. Based on that, we are able to confirm whether the intended purpose of intervention has been achieved or not. Coming to the next slide, in which I would like to show you the basic framework of this Indian standard, which is under progress. I take liberty to share the flow chart, which is in almost final stages, and the finals. This flow chart suggests us that how the structural audit process would take place from start to finish. Now, in this, we have defined 2 stages. First stage is about the condition assessment, in which our aim and objective is the audit and the scope of work to be defined. Then the owner will appoint a structural auditor. The structural auditor would carry out visual inspection of the structure, and based on the visual inspection, sometimes the auditor may do some basic non-destructive tests also at this stage, and then prepare and submit the visual inspection report. If the aims and objective of the structural audit report is fulfilled, then this audit is considered as to be completed. But if the building has some deteriorations and the building safety audit do not suggest it to be a safe building or structure, then we have to move to the stage 2. And in this stage 2, we have to assess the damage, deterioration, and the evaluation of materials, construction material or construction quality, carry out non-destructive tests and other tests to assess condition of the existing materials, structural components by independent laboratory or by the structural auditor as decided by the owner. The NDT test report should also include the following: the objective of the NDTs, the brief about the various tests performed, methodologies adopted for the test, analysis of data, derived conclusions, and recommendations based on the test. Preparation of test report by the testing agency and review and recommendation by the structural auditor. Next step is estimation of demands and the capacities. Now, this is a very important point in this stage 2 audit. Once we have undertaken the testing and condition assessment aspect, we know the strength of the structural elements and other condition aspects we know. We, as per the latest standards, we have to analyze the building with applicable loads and forces and see what is the requirement of the structural elements. Say for a column of say 600 mm by 600 if the building has, and if as per the analysis, the requirement of the reinforcement steel is say 2%, and that is what we consider as a demand, that it has this much of bending moment and this much is the forces, actual force and other things. So that is the demand to be taken care in the terms of strength demands. And what is the available capacity has to be analyzed. Now capacities will be calculated based on the available concrete strength or maybe on any other material if it is having the strength of the material, the reinforcement if it is having the percentage of reinforcement or the content of the reinforcement in the system, and based on that, what is the capacity of taking care of the moment and what is the capacity of taking the actual forces. So if our demand of say strength and the capacities of the strength are matching, it means our building is safe. If our demand is less and the capacities are more, we would say it is a kind of good, or I would say conservative condition, that we are having some reserve capacities, additional capacities. So again, safe. But if the demand is high and available capacity is less, then there is a gap. Capacity is less, but our safety requirement demand is high. It means we need some strength. This gap needs to be filled with some strengthening system. Some intervention is required. So based on that, identification of the deficiencies and inadequacies that is identified. And then based on that, the report is to be prepared by the auditor to guide the owner client that the building is, based on the visual survey and other aspects, building is safe or it requires some strengthening, local strengthening or global strengthening. Sometimes the building overall is fine, but a few structural elements are deteriorated because of maybe some higher moisture content or maybe some other attack of the environment. So if it is a local issue, then we can just repair those local structural elements and then certify the building. And if the building overall has a lot of issues almost everywhere, then it is a global issue and it has to be dealt with a proper system of complete rehabilitation or retrofitting intervention. And then the audit part is generally considered to be closed as stage 2. And then the work of the execution agency comes into picture. So selection of the competent retrofitting execution agency or retrofitting contractor comes into the picture. And before that, because in this part 2, only we know what is the gap, what is the demand capacity gap or the deficiencies. Competent structural consultant has to design the remediation. If remediation is covered within the part 2 of the audit, then it is fine. But if in the part 2 of the audit, it is only the recommendation part that building needs some remediation, but the design of remediation is not covered in part 2 of audit, then remediation design will come into part 3, and execution by the competent retrofitting contractor will be stage 4. And then, as I discussed earlier, verification or validation of the intervention comes at the stage 5. Now coming after all these discussions, we know the importance of the structural audit. We know briefly about the process or steps involved in the structural audit. Now coming to the career opportunities we have. Now, I am very sorry to say that in our country, we have very, very less competent structural auditors. At this moment, what we find in the market is if any building is under distress, people do not know whom to approach. The owners are confused. Sometimes the delay of intervention is because they do not find competent professionals to deal with the situation, and the things linger on. Sometimes people approach to professional architects. Now, the architects are not trained for the retrofitting design or the structural audits. The architects are trained to design the new buildings. But if they see the existing buildings to be repaired, because in their eyes it is only to be repaired, generally buildings get some basic repairs, whereas probably the building was requiring structural strengthening and retrofitting measures. So sometimes because the people are not aware and the competent professionals are not available in the market, the owner makes a wrong choice or wrong decision to just blinding the distresses or the problems. The cracks are just repaired with the help of simple plastering material, and not investigate what is the reason of these cracks and how to actually cure the cracks. Now, if again I discuss in terms of our human health versus building health, if we just ignore our health, and if there is a requirement of a doctor, but we do not go to doctor and just take some crocin or paracetamol type of medicine to just cover up some time that we are ignoring the disease which are there, the disease may become grave, and sometimes just like cancer, if not treated at first stage, it becomes fatal. Similarly, for buildings, if there are structural issues and those structural issues are not taken care timely, those issues become very, very grave, and then you see a lot of accidents, buildings, balcony falling, or maybe slab falling, or maybe building collapsing. So these kinds of incidents continue to happen. So career opportunity is that we should train ourselves to be a good auditor. To give you just an eye-opening that in United States, more than 50% built environment which is having life of more than 45 years. So a lot of retrofitting requirements or the important rehabilitation requirements would be there for the 50% built environment, which is already there. In United Kingdom, more than 79% built environment is 25 years old. So in that scenario, the new construction is maybe annually 2%, 3%, but you have 79% built environment, which is available for the audits and the retrofitting rehabilitation. In Germany, it is 89%, which is having more than 45 years of age. In Italy, it is 90%, which is having 25 years of age. In France, more than 55 years of age is 66% buildings, whether they will go for redevelopment or preserving the buildings. So these are some statistics which we have collected. And if we see the another way that in the terms of bridges, that was the building slide, and in bridges aspects also, almost every country has lot of built environment. 60-70% in Australia, the bridges are 50 years or more than 50 years old. So all these kind of potentials in Russia, 70% bridges are more than 50 years old and something like that. So if we consider a general life of a structure 50 to 100 years, and if the building or structure has already lived for 30, 40, 50 years of life, it means now there's a time to elevate the capacities of those structures to meet the current requirements, and a lot of intervention rehabilitation is required, and for that structural audits are required. So some countries have taken appropriate actions for that. In United States, in January 25, they have mandated that the first inspection is due by January 2025, with subsequent inspection every 6 years. So a lot of important aspects are being taken, important decisions are being taken all over the world. Thailand has also mandated structural audits every 5 years, along with annual inspections of key safety systems. In Singapore also, structural audits every 5 years. In Hong Kong, all buildings having age 30 years or older have to be mandatory inspections, and for residential buildings every 3 years. In Malaysia, again, there are inspection of multi-storied buildings requirements periodically. In Japan also, as per the law, the buildings constructed before 1981 have to be earthquake resistant retrofitting as per the law. In our country, if we see a lot of accidents happening now, I do not want to read about all these accidents, all these collapses, but must tell you that there is a grave need in India for saving our existing built environment. We need competent structural auditors, structural consultants who can assess the building, who can do the condition audit, and then the required buildings should be taken up for the required intervention or the strengthening requirements. So some authorities have already taken some decisions. In India, in Delhi, zones have been divided. MCD has already notified that the buildings constructed before 2002 have to be undertaken for structural audits and should meet the safety requirements. In Mumbai, also structural audits being planned for more than 1,000 buildings, and approx 13,000 buildings to be evaluated overall in Mumbai. In Navi Mumbai, 527 buildings identified as hazardous under Section 264, and these all need to be audited, and the safety of these 527 buildings have to be ensured, and so on. Even in Noida and Ghaziabad, if we see, more than 100 buildings are found to be unsafe in Noida itself, as per the survey of 2018. In Ghaziabad, 102 buildings declared unsafe in 2020. So a lot of everywhere, if you see Noida, Greater Noida, Gurgaon, Chennai, Thane, a lot of information you can see from the newspaper, and in every day we see some kind of fatalities also. So government is also taking appropriate steps. Florida Authority has recently put up a expression of interest for structural auditors, consultancies. They are now empaneling the consultants. So similar will be the need everywhere, not only in our country, worldwide. The structural auditors are required, and in our country especially, because our engineering courses are not making the awareness about the existing buildings and the structural audit systems. So there is a continuous need of training to become a structural auditor. We in our organization have taken one initiative. In this initiative, we have now decided to train the structural engineers to become good structural auditors. Within this process, we have launched one training course, which is now completing next week. It was a 12-week course, and more than 25 participants have already registered, and they are now going to be completing their course next week. So they would be becoming the structural auditors with complete technical know-how. In these 12 modules, we taught them about the introduction of audit, identifying the structural challenges. There are different types of distresses, how to identify those distresses, what type of issues make the buildings distresses complex, like in under what circumstances the corrosion takes place, cracks, and what is the need of waterproofing in certain areas, dampness and leakages are, how to deal with these kind of issues, and complete 12-week course. This was in a hybrid mode, undertaken every Saturday full day course. So it was a kind of 12-day full day course for the structural engineers to become skilled structural auditors. So this was the initiative from our organization. Probably we will conduct another similar course by end of this year. So our aim is to train the people to become good structural auditors. They should be working in line with the national standards. They should be working in line with the IS code for structural auditors, and they should have competence and technical know-how of the Indian codes as well as the international level of knowledge. At ISO level also, there is a lot of initiative and some standards being developed for the structural audit and preserving the buildings from corrosion and the age-related issues. So we hope in our country the competence will be there to handle this available infrastructure. And with this, I welcome any discussions, any questions, so that we can conclude our today's talk.
Excellent presentation by Engineer Amandeep. Vikas, we must be having few questions.
Yes,
So
sir. Yes, sir.
please read questions and then Engineer Aman will reply to.
Yes, sir. Yes. There is one question by Mr. Ravi Sasdeva. In 7-story building, rebound hammer test was showing 70 MPa average strength in column, but in half cell potential test, it was showing 90% corrosion probability. Please suggest what action should be taken for repair retrofitting. It is a 37-year-old building in Delhi.
Very
Grade
good
of
question.
concrete
Actually,
informed
I
M20.
understood. Yeah, I understood the complete condition of this building. Now, this building is almost 37 years old and showing good results with the rebound hammer test. Now, I must tell you that a rebound hammer test is the surface hardness test. It is not the strength test. So, if there is one scenario, one natural process which is called carbonation. On the surface of the concrete, there is, if the ingress of carbon dioxide, and we find that in the concrete we have calcium hydroxide. When calcium hydroxide reacts with the carbon dioxide, with the age, it becomes calcium carbonate, and we all know that calcium carbonate is very, very hard. So our surface starts becoming harder and harder with the age. So if we conduct a rebound hammer test of a building, say more than 10 years old, which is exposed to the environment, it is likely that you get a very good result with the rebound hammer test. Result means the rebound number. And sometimes we do a mistake of just correlating the rebound number with the compressive strength of the concrete, which is a very, very wrong aspect. So rebound hammer test give you the surface hardness, and if the structure is new and it has a good correlation with the core test, or the similar concrete has been correlated with the hardness of that kind of system, then probably you would get a reliable compressive strength of concrete, say that too in the range of 20 to 25% variation. But if for the building which have aged more than 10 years, rebound hammer test we would give you just a kind of level of carbonation and the hardness levels. So giving a good high number of carbonation is the indication that the building is having good age. So it is clear that 37 years of age is giving good high rebound number, it's fine. Now coming to your point of half cell potential test, which is giving very high probability of corrosion, 90% probability of corrosion. It means the currents are very high inside. It is again supplementing the system that because the carbonation is high, the pH, the alkalinity of the concrete near the reinforcement is going down. And many of you might be knowing that it is the alkalinity of the concrete, which is a kind of passivator for the reinforcement steel to prevent it from the corrosion or rusting. So if our pH in the concrete near the reinforcement is more than 11, then there is a very low risk of corrosion in the reinforcement. But because now carbonation has taken place, your rebound number is high, and your half cell potential test is indicating very high currents. It means very high probability of corrosion. It is very clear in this scenario that the inside condition of the concrete or the reinforcement level is not good. Either carbonation has reached to the level of reinforcement steel and the pH or the alkalinity of the concrete has gone down below 10.5 or 10. If the pH is below 10, then again there is a very high risk of corrosion. So it is requiring a good level of intervention. Now your question is what should be done? Till now I have just analyzed the situation. Now what should be the appropriate measure to come out of this situation? Now for that you would have to check at some locations whether the corrosion has already started or it is at a nascent stage. It is a stage 1 of corrosion, or the corrosion is very, very deeply spreading inside the building. If the corrosion has, though the probability showing 90% means that already there should be good level of corrosion at some locations, at many locations. But suppose it has not started at this moment, it is giving the probability, but concrete was good and the reinforcement has just started. Then you have the options of trying to improve the alkalinity, or you can use some kind of corrosion inhibitors. Now, corrosion inhibitors are also of 2-3 types, basically, which you can use. One is a kind of admixture type of corrosion inhibitor, which you can mix in the cement slurry and do the grouting. Because if there is a honeycombing, then because of the honeycombing, there will be easy passage of carbon dioxide and air and moisture into the concrete. So you want to close that. So you can do the cement slurry grouting, pressure grouting, and in that you can use this corrosion inhibitor. Second option could be you have self-migratory corrosion inhibitors, bipolar migrating inhibitors, which you can spray on the surface and which can go inside. And generally they travel distance 25 to 40 mm. The corrosion inhibitor can go and it automatically finds out where the reinforcement is and it makes a coating on the reinforcement steel. Because of its bipolar nature, it closes the cell on the galvanic cell process, the current process, and prevents or preserves the reinforcement from further corrosion. Similar to some other chemicals, some other types of corrosion inhibitors also there, which you can put like a capsule, just like we take capsules or we take injections. Similar, the building also needs sometimes injections or capsules. So these capsules are inserted into the buildings. These capsules have some fumes of this corrosion inhibitors, and that can also help in preserving the reinforcement steel. This is the treatment if we do not have any strength issues. But if we have some strength issues also, then again, it is a matter of the structural engineers to work out the demand capacity, and then you can work on the strengthening or the required retrofitting measures. I hope
Yes,
I hope I could answer the question.
Thank you, sir. Mr. Prithviraj Singh Boke asks, which IS code is followed for retrofitting and structural auditing?
Well, just as I told, at this moment, for structural audit guidance process, the standard is under making, and probably by end of this year, that standard would be available. The number has not been fixed. Once the standard would be circulated for wider comments, and after the finalization, only the IS code number is given. So at this moment, it is at a P-draft level. We say that it is a committee draft document. Other documents which you can follow for the structural retrofitting is generally available based on the earthquake safety criteria. IS 15988 can be followed, and IS 13935 can also be used for the structural safety remediation purpose, I would say, not for the audit purpose. For audit purpose, the standard is under progress.
Thank you, sir. Mr. Ravi asks, I think there is a question or suggestion, I don't know. Demand against capacity shall be worked out based on latest IS codes. So question mark, as if we calculate demands
Now,
based
it
on
is a very
latest.
good question. Now, I have understood his intent. Now, if the building is constructed, say, in 2005, and at that time, the applicable standard was, say, earthquake safety standard was IS 1893 2002, and IS 456 2000 was available for the general design. Now, suppose if in 2025 we are doing the audit and we try to assess the demand and capacity gap. So, what option we have? One option is we calculate the demand based on the standard which was used for the design at that time, 2002 code for the earthquake forces, and IC 875 continues to be same. Wind code changed in 2016, but otherwise other standards were basically at the time of the construction, at the time of original design were 2000 to 2002 versions. So there is, if we talk about the legal safety requirement, then the standards which were applicable at the time of design is good enough. But if the owner desires to have the safety level to meet the current safety level requirements, then we will have to calculate the demand as per the current code requirements. So legally, one can use the standards of the time when this building sanction was provided. So the standards applicable at the time of building sanction is good enough as per the legal requirements. But definitely that is the minimum requirement. We can always upgrade. And if the owner desires to upgrade the safety level to meet the current codal safety requirements, then the demands have to be calculated based on the current requirements, and capacities are the capacities based on the non-destructive test and the available data information you have. You calculate the capacity and then you can fill the gap. One thing more I would like to add on this. Sometimes what happens that if we legally we calculate based on the applicable code and the capacities are found to be lesser than the requirements. The demand is more, capacity is less. Then generally we suggest, because if the intervention is required, if we are going to strengthen the building, then why not strengthen to the current safety level requirement? So in that case, we generally guide the owners that, of course, at the time of design, the safety level requirement was a bit lesser, but now the safety requirement is a bit higher. If we are taking up the building for the strengthening overall, why not to strengthen to the level what we require today? And many a times owner agree that if I am going to spend 5 lakh rupees for the strengthening to match earlier requirement, and if I add one more lakh, say 6 lakh rupees, if required to be used for making the safety level to current requirement, then why not spend 6 lakh rupees instead of 5 lakh rupees? But the safety level would be to the current safety level. So it is a kind of convincing also to the convincing owner to reach the current safety level requirement.
Yes, sir. Thank you, sir. Mr. Ravinder Shekhar asked how the settlement of foundation of structure are audited and foundations are assessed.
A good question, but I would say that settlement of the foundation is very difficult to assess. That overall settlement is how much, but that is also not our concern also. Our concern is the differential settlement. If a building settles uniformly, if the uniform settlement is 50 mm, we are not bothered because there is no distress being caused because of the settlement into the structure. Our challenge is the differential settlement. Suppose one column settles 10 mm, other column settles 20 mm, then this 10 mm differential can create an additional bending moment and additional shear forces, torsional moments. So the distresses can be developed because of this differential settlement. So our aim is to check the differential settlement, and differential settlement can be assessed through some, I would say, we get some signs of distress in the building because of the differential settlements. Our brickwork shows some cracks. There's a pattern of cracks which can tell us that there is a differential settlement. Or maybe sometimes if the differential settlement is more, we get to see some shear cracks in the beams, and sometimes we see some cracks in the columns also. So we get to know about the differential settlement by seeing the structural condition of the building as such. But bottom line is that overall settlement is very difficult to measure after some years of the construction.
Thank you, sir. There are few questions in the chat box also. I'm reading one by one. Mr. Gokul Krishnan asked, for a composite bridge pier where structural steel is encased in concrete, how do we assess the failure such as shrinkage cracks of concrete inside the structural steel? Also, how do we measure where the crack starts and ends inside the concrete core using NDT methods?
Okay, these are basically two questions. First, I would answer the second part of the question. If there is a crack inside, then how shall we measure that from where the crack? Now, for that, we have advanced equipments, and generally the ultrasonic pulse velocity helps in finding out the cracks. Now, generally what we use as a SUVV testing is for the velocity, ultrasonic pulse velocity. And based on the velocity, we try to find out the integrity of the concrete inside. But this UPV test can also help us. We have some latest equipments which can help us in identifying the cracks, starting point, and the extent of the cracks. So with this, and there are some other equipments as well which can help you identifying the extent of the cracks or the thickness of the cracks. There are some scanners which can help identify the extent of the cracks. So this is the second part of the question. Now, first part of the question, that there is a composite structure in which you have structural steel member inside and you have the concrete encasing for that. And now you want to assess the I just forget what is to be assessed in that.
1 second, sir. 1 second. I read it again. For a composite bridge pier where structural steel is encased in concrete, how do we assess the failures such as shrinkage cracks of concrete
Shrinkage,
inside the
yeah.
structure?
Yeah, your question is about the shrinkage inside the structure in this kind of pair, or where we have structural steel inside and a lot of say thickness of concrete is around that. Now, first of all, shrinkage, the shrinkage is of two types. One is drying shrinkage, the other is thermal shrinkage. Generally, drying shrinkage is visible within some hours of construction, and the thermal shrinkage comes out after, say, maybe 2-3 days or more. Now, if the concrete is having very high grade, the concrete has very high OPC content, then there might be issues of thermal shrinkage later on. Now, I would cover those two aspects on that. First is how to prevent these kind of thermal shrinkages. Now, to prevent this, IS 456 says that the OPC content should be limited to 450 kg per cubic meter. If it is such normal nominal value of OPC, then likely that with the normal thickness, say maybe 900 or 1000 mm of concrete, there should not be much thermal shrinkage problems. But if the cement OPC content is high, then we should test it before using into the structure, that what kind of impact of this high OPC content is. Now, if the OPC content is high, if the thickness is high, and it is likely that the thermal shrinkage can happen in this structure, then we should try to use chilled water for the concrete and appropriate measures to keep the concrete cool at the time of construction. So suppose you have taken all the measures, all the best engineering practices you are using, and then now you want to evaluate whether there are thermal shrinkage cracks inside or not. Generally, the drying shrinkage cracks will be appearing on the surface, whereas thermal cracks can be inside the concrete element also. So for that, it is a thermal, whether the reason is thermal crack or maybe any other crack. If there is a crack, you can scan it through some scanners, or ultrasonic pulse velocity test can help you identifying that whether the thermal cracks are happening inside or the concrete is sound inside. Dr. Dhawan, would you like to say anything about it? You are expert of this area. Dr. Dhawan, you would like to say anything?
Yes, you have really explained very well that the cracks, actually, if you don't do the right thing, water cement ratio, proper placing, compaction, and curing, and then see we have got various type of temperatures. I mean, working in arid zone like Rajasthan, where the summer temperature goes to 45 degree with no relative humidity. So the climate difference, our way of working has to be different. So here, what I would say that the upgradation of knowledge that every engineer or the worker needs to know which part of the place in our country, whether he's working in the marine area or hilly area or Delhi composite weather. So there are many factors. So this concrete technology, one has to keep reading and updating his knowledge, which has to be a coordinate process and its application. So this is what I would say.
Right, sir.
So any more questions?
Yes, sir. Yes, sir. There are few questions also.
Please
Mr. Nirmal asked, Mr. Nirmal asked, during the ultrasonic pulse velocity test, we encountered doubtful results. As per IS recommendation, what additional tests should be conducted to further assess the quality of concrete?
Okay. Now, if as per the UPV, we find the velocity of the UPV is moderate, say if the velocity is less than 3.5 kilometers per second, then we consider this kind of concrete to be a doubtful concrete. Doubtful means it doesn't mean that the concrete is bad. It only indicates that there may be some voids inside the concrete, and there may be some issues related to the durability over the time, because it can allow some penetration of air and water inside, because it has some porosity. But if the UPV is less, it doesn't mean that concrete is bad. But of course, it is an indicator that the strength is not very high. If the velocity is less than 3.5 kilometers per second, we generally consider that the strength of the concrete would be normally not exceeding 25 MPa class strength, or maybe M25 grade should be the maximum considered strength for this kind of concrete if the UPV value is very, very moderate, maybe 3 to 3.5 kilometers per second. So we conduct core test, we conduct half cell test, we conduct some other non-destructive tests also. And with the integrated understanding of the findings of all the tests, suppose half cell potential test is also indicating corrosions. So if the corrosion probability is high, it means that there are internal cracks around the reinforcement. So concrete spalling may start later on. Maybe the velocity is less because of some internal cracks, and due to high probability of corrosion, or maybe due to initiation of the corrosion process, the concrete is cracking inside. So this may be another indicator. If the core strength indicates that the strength is 15 MPa range, so it is complementing the result of the UPV value. So we will have to see what is the objective of our NDT, and based on the objective, we conduct the related other non-destructive test and try to correlate the findings. So it helps in assessing the condition assessment. Now there are many aspects, and based on that, finally the auditor decides to take up the action on the interventions.
Yes, sir. Thank you, sir. Mr. Naresh Prasad from Nepal. He asked, in PSC bridge of 30-meter span, due to debris in the case of landslide, some part of the deck slab is broken. What will be the probable retrofitting solution for that type of problem?
In that case, if some part of the deck slab has already got damaged, so it will be now a kind of structural retrofitting strengthening requirements. So the structural audit has to redo the complete structural analysis, try to see the demand. Now, what is the demand? Now, where the distress is high, the capacity is almost gone. So the complete demand has to be met with the retrofitting intervention methods. In this kind of retrofitting intervention, one can use high strength concretes. Some people can use maybe FRP, carbon fiber reinforced strengthening systems, which may be comprising laminates or wraps, or maybe a combination of grouting, micro concrete jacketing, laminate, wrapping, or maybe another methods of strengthening. So it will be the requirement based strengthening design, and the design has to be decided by a competent structural engineer.
Thank you, sir. There is question from Naveen Kumar. Which test is suitable for identify internal defect of deck slab?
Deck slab, okay. Now it is a bit difficult in case of deck slab, because now in case of deck slab, your bottom steel, corrugated steel element acts as a tension reinforcement, and you have some shear connectors, and the upper concrete is a thin element. Now, if the crack is there on the surface of the concrete, then it is likely that there is a deflection in the deck slab system. In deck slab system, generally the supporting is provided by the steel elements. Now, there is a challenge in the deck slab system that the structural steel elements would have high strain, permissible strain. Now, the deflection limit, the permissibility is high because the steel is a ductile material. Whereas concrete is not that ductile. Concrete is a kind of brittle material. So even though the structural load carrying capacity is met with the help of steel system, the deflections, or I would say the strain, because in a normal concrete, we allow 0.0035 value of the strain in the concrete. So if we see the strain limitation of the concrete with respect to the deflections allowed for the deck slab system, sometimes we find the concrete need to be cracking if we allow that kind of deflections in the deck slabs. So condition assessment would be just simply based on the analysis that what is the deflection and whether the concrete is undergoing higher strains. And if it is higher strains and the surface cracks are appearing, it is indicating of the fact of the member properties. So nothing to worry about. Strength, from strength point of view, it is fine. You can simply fill the cracks and go ahead. But if you want to assess the internal condition of the concrete, though it is a thin element, again we can try to use UPV test results. But the UPV test values will not be similar to a normal RCC test results. It has to be seen in light of the deck slab system. So a competent structural auditor would be able to assess well the values based on UPV values, but it will not be easy for a normal person to understand, because the codal guidance are not giving the UPV values correlation for the deck slab system.
Thank you, sir. Mr. Ramesh requests you to recommend some names for structural audit of a residential multi-storied building located in South Delhi.
Sorry, I could not get the question part.
Mr. Ramesh requests you to recommend some names for structural audit of a residential multi-story buildings located in South Delhi.
Structural auditor's name. Okay.
Yeah. He requests you to suggest some names.
If the structural auditors, if required for the Delhi region, South Delhi region, what I understand is that many of our IS structural consultants are competent to do that. In South Delhi, Wintech consultants are there who can do this kind of work. Dr. Abhay Gupta from Skeleton Consultant is there. Our organization, Creative Design Consultant, is there. So if you search, you would find 3-4 good names of the structural consultants who have capacity to deal with the existing buildings. And in our organization, we have complete competence of dealing with right from the structural visual audit to till remediation design. So we have special design teams, we have special audit teams. So in our organization, we have complete competence. However, other good consultants are also here in Delhi NCR, and any good consultant can be approved. I have just general suggestion that please don't recommend to go to an architect's office if we have structural issue. For any structural issue, please recommend to go to a structural engineer, a competent structural engineer and structural consultant only.
Yeah, thank you, sir. This is the last question. Mr. Dharmender Kushwaha, research scholar from Central University of Haryana. He asked, what is the chances of getting job and initial salary after taking training for 3 months as organized by your team? In fact, I am trying to get job in structural audit and retrofitting work after completion of my PhD. How may I contact you? Is there any other resource to get a job as a
I
fresher in
would
this
say
field?
that it is a great scarcity of the structural auditors, and a lot of job opportunities are available in this area. Now I am finding many people are doing PhDs and major projects of their MTech thesis in this area. In our organization, we have two competent PhD holders who have worked in one has done completion of his PhD in structural assessment, equipment testing part, and other is having their competence of having assessment of PhD in condition assessment and the durability assessment part of the buildings. We have offered both of the PhDs to our office to continue with that. We in our organization taking up the research projects also, and we have one research project already undertaken in Delhi, and another research project is under discussion, and probably we will be taking up another 1 month. So opportunities in our organization is there, but of course, as an independent, or if you are trying to have you as an entrepreneur, you want to go ahead. Even then, also there should be good opportunities ahead. But of course, before going as an entrepreneur independently, one should have good experience of dealing with these structures, and with a good consultant, one should work at least for 3 to 5 years. And if you can contact us, if suits, we can think of you. And otherwise, as I told, Wintech consultants, the Skeleton, and there are many other good structural consultants you can approach, and they would definitely look the opportunity in this area, and they can definitely offer you.
Yes, sir. Thank you, sir. This is the last question, sir. Mr. Naveen Kumar asks, why impact eco test is not generally used for assess the structural condition like UPV, RH, half cell, and carbonation?
Well, impact eco test is also a good test. The only limitation is the availability of the equipment. It is not very easily available with the testing agencies or consultants. And impact eco is also generally not considered as a definitive test. So other tests are again required also. So probably in near future, impact eco test will get popularity as per the availability and more knowledge about the as the audit work will be spreaded, as the people will get awareness for the complex buildings, probably people would be ready to spend more for the assessment audits, and then probably more and more better tests would be popular in time to come.
Thank you, sir. These are the only questions.
India, Amandeep, excellent presentation. I'm sure persons who have listened to you are lucky, as they cannot find such things in the RCC books. The given message is that is a very important subject, and we need really competent structural auditors. And I will request our president to organize this training. We have been imparting training to the young structural engineers. So this year we should organize this training for the benefit of our structural engineers. This would be really very, very, very helpful for the person to know what is the status of structure now, what remedies are required, and if it needs strengthening, we will do that. But we really need a competent structural auditor, for which upgradation of skill of even the structural engineers is very, very, very essential. So with those notes, once again, on behalf of Institution of Structural Engineers, I thank Engineer Aman Deep to spare his valuable time and contribute his knowledge and experience in such a wonderful and important field. Thank you once again. And now the next webinar would be next month, the new topic and the new speaker. And then persons who are not a member of I will recommend and request them to be a associate and become a member of this institution, where you will have a lot of knowledge and information. And with that way, you will be able to update because learning is a continuous process. And with that note, I conclude the session. Thank you once